Good morning to Dr. Lim. Me and my group, which is from Group AW, will explain, will demonstrate the learning outcome of debugging machine learning algorithm, which involve several parameters like regularization, train, cross-validation, and test data set. So for the first slide, actually there is a total three slide that will be presented by us. So I will start first. The first question is week 10 tutorial question 1, which is uh, about the diagnosing bias and variance. So here we supposed to learning we are supposed to learning the algorithm by performing less well than we are hoping, indicate as a J cross validation and J test. Uh, the question is it a bias problem or the variant problem? And end of the at the end of the explanation, I must explain why the higher is the degree, why the higher the degree polynomial, the last error is the training error of the J train of the learning algorithm. So first of all, let's analyze first the algorithm. The x-axis here is indicate for the degree of polynomial, and the y-axis is displayed as an error. So here there are two graph here. Basically, we can verify that the left side is for the bias, and the right side is a basically we assume is a variance. Yes, it's still a variance. So from the left side, for the height case, for the height bias case, there is a case that underfitting. Yes, there is case underfitting. What we can find from here, both cross validation and the train error are also going to be high. So if our algorithm here is suffering from the bias problem, so the train set error will be high, as well as the cross validation error, or maybe it will be might be close or slightly high. So it will lead to the underfitting, as the J train will be high and the J cross validation will be equal to J train. So this kind of combination, these two combination, um, basically is a sign that indicate that this is a high bias. So it will lead to the variant will be overfit, as the J train will be low, affect the JCB to be greater than J train. And so from all the parameters that we get from here, uh, why the higher is the degree of polynomial, yeah, indicate if the degree of polynomial D here is 1 and the D is a 4. So why the degree of polynomial, why the higher is the degree of polynomial, the less error is the training error of the linear algorithm. So what I can answer from this question, I can assume that maybe I assume it's about the linear regression, which is that if the true underlying relationship of the predator and the response is linear or nearly linear, which we will never know for sure. Yeah, increasing the degree of the polynomial regression, which is up to a point, will generally fit the data better as it increase the curveness of the baseline and vice versa. So in our case, in this case, I will bet that the underlying relationship is somewhat non-linear. So the higher the degree of the polynomial, the better the fit line. So so I think maybe at some point it will lead to the overfitting. So if you ask to build a predictive model, So the test error will be what we need to have to fix the problem. So some cross validation is need to be done to see the best degree of the polynomial itself. So that's all from me. To answer the question for the week 10 tutorial question 1, I will pass it to Khairul Haiqal to present the next tutorial question. Thank you.
Good day. Today I will explain about this question. Suppose your learning algorithm is performing less well than you were hoping. Is it a bias problem or a variance problem? First, we need to examine whether the relationship between the degree of polynomial D and the underfitting or overfitting of our hypothesis. We need to distinguish whether bias or variance is the problem contributing to bad prediction. High bias is underfitting and high variance is overfitting. The training error, this one, tend to decrease as the degree of polynomial increases. At the same time, the cross derivation error tend to decrease as we increase the degree of polynomial to a point, and it will increasing as the degree of polynomial error increasing, forming up a concave curve graph. Now I will explain why the higher is the degree of polynomial, the less error is the training error of the learning algorithm, which is in this part of the graph. This is because as we increase the degree of polynomial, we are able to fit higher training set better and better. This indicates a high variance problem where the degree of polynomial was too large for the dataset. Thank you.
Hello, my name is Aiman Shabri. My page number is B0217105052. Okay, today I will explain about the linear regression with regularization. Okay, in this linear regression, we have the model of the H theta with theta 0, theta 1, theta 2, theta 3, and theta 4. This equation will make the parameter which make the graph in overfitting. Okay, in case to reduce the parameter in the theta 3, theta 4, theta 2, we will add the extra regularization parameter, which is a lambda over 2m summation of theta 2j. Okay, when there are two type ways, is lambda is higher and the lambda is 0, which we regularize at the theta 4, theta 3, theta 2, theta 1. Okay, if the lambda here is a very small, we'll make the cost function in front to the original cost function, which will make the graph is overfitting because the lambda is very small and cannot regularize the theta 4, theta 3, theta 2. Okay, when the lambda here is a large, when the lambda is large, we will regularize at the theta 4, theta 3, theta 2, and theta 1 only. Will make the theta 0 out of it, because when the lambda is very high, with the summation j equal to the 1 to the theta 1, theta 2, theta 3, will make the theta 1, theta 2, theta 3, theta 4 is close to 0. When close to 0, will make the graph like this. We call it underfit straight line, because only theta 0 will have. Okay, regulation at theta 1, theta 2, theta 3, and theta 4. Okay, when the lambda is in the middle of the large and the small, will make the graph just right, because we'll regularize the theta 4, theta 3, theta 2, theta 1 in the half only, and then we'll make the graph will just right. As say before this, when the lambda too small, we regularize the theta 1 until theta 4 only small, will look small only and make the graph will be in overfit. Okay, this is the explanation of how the cost function with the large lambda will result the theta being too small. And I also explained how the fitted model is occur. That's all for me. Thank you.